Hey, let's discuss about Python classes. Before we start classes, I just want to show how a dictionary looks. Why I'm saying talking about dictionaries because it'll be easy for you to understand the class objects and the dictionary objects as well. So here, what I did was I have initialized a small dictionary. I mean, a simple dictionary called C. It's an empty dictionary. I'm going to print the type of it. I'm going to say what is the name. Say, for example, I want to say the name is Stacy and the age is 30. When I go and print it, you can see that the name is Stacy and the age is 30 and the type is dictionary. Okay. If I want to go and access, say, for example, if I want to go and access the name of that dictionary, I can say simply the dictionary name, and then you can get the value as Stacy. And similarly, you can go and update the value also. Say, for example, if I want to go and update the age as 40, now it will get updated as 40. Okay, so far so good. You have a simple dictionary. I think we already discussed this particular thing. A class is something similar. Okay, I mean, it is not same, but it's something similar. So for example, how you define how you define a class is by saying class followed by the class name. So for example, I want to capture the breed of dogs. Say I have a dog class, and in this I'm going to initialize by saying that you have an init function, and then you have a couple of arguments like height, age, and breed. You don't have to use the init function. Say for example, uh, I have a class, and in this I say this is my class, and in this I can say uh, name is equal to blah. I can say age is equal to say 28, and then I can say location is equal to say India. Okay, and then when you have initialized it, you can say my class is equal to my class. Because I don't need any arguments to be sent, I don't have to do it. I'll say simply initialize it. And then when I go and say my class dot, you can see couple of arguments are available. You have see age, location, name, and some other like annotations class. You don't have to see all that, but you can see like, for example, if I want to go and access name, you can simply use blah. On the contrary, you can use some initialization function. You can use something called a self, and wherever you pass the self within this class, you will have all those variables accessible to it. Okay, this is also a class wherein I do not have any self, so I can simply access the variables by calling the class name dot variable, just like how you did in dictionary. Like in dictionary, you have a dictionary followed by the key. Similarly, here also you can say dictionary followed by the key name. In this case, the key name is name, so you're getting the value called blah. Um, we can have more advanced features to class by using self. So what I'll do is I'll take an object, like I'll declare a class called dog. And in this dog, I'm going to capture the height of the dog, the age of the dog, and the breed of the dog. So how you do that? So simply I'll say dog followed by init, and in this init, I have something called a self followed by three arguments. So whenever I initialize this class dog, I need these three arguments, the height, age, and breed. And when I initialize it, it will be captured into the self by this self dot height is equal to height, self dot age is equal to age, and self dot breed is equal to breed. Okay, I have like I declared a class dog, and when you create an object called German Shepherd, say it'll throw out an error because you do not pass these arguments to it. I think we saw this error in functions, right? When you declare a function with some arguments and you uh, do not pass the arguments while calling the function, you see the same errors, positional arguments. Okay, so what I'll do is I'll pass the positional arguments. I'll say the height is 1.5, the age is 5 years, and say the name or the breed is German. Okay. Now German Shepherd, this is an object. Okay, because this object, like if you go and print the object, you can notice that this is a main class and it is stored at some memory. There's some memory address. Okay, and when I go and print the age and height and breed, you can get all the values. Okay, whatever you declared in the init, all those values are now available in this object, German Shepherd object. Okay, on the and in addition to this, you can have more functions to it. Okay, we discussed one concept in functions. In functions, what we saw, whichever variable that you declare in that function is limited to that particular function. Okay, similarly in class, whichever variable that you declare here, or whichever functions that you declare here will be available only within this class. So I'm declaring one more function called about, and in this about I'm passing the self object. Okay, so when I pass this self object, all these arguments, all these variables are available here as well. And then I can access those variables by simply calling self dot. So if I want to access the breed name, I'll simply say self dot breed. And I can also access the age by calling self dot age. And I can also access the height by calling self dot height. Okay, let me rewrite the class function. And I have initialized a German Shepherd by saying dog 1.55 in German. And when I call this German Shepherd dot about, it is going to print this by replacing all the values. So I think you already discussed this uh, variables, right? Self dot breed. I mean, we already discussed this format string where it is going to replace all these objects and with the respective values, and it's going to print. Okay. Similarly, I can initialize one more object like street dog, and when I do this, you can notice that when I call this about function, it is going to behave the same way. Similarly, you can have one more class like with name and age. I can say self dot name is equal to name and self dot age is equal to age. And then when I initialize p1, it is going to do the same thing. Instead of self, I can also say capture, and it will behave the same way. Like capture dot name is equal to name, capture dot age is equal to age. But this is the common way of doing it. 1 minute, Raja. 1 minute. Oh, Sanam. Okay. So we can see age and name. We can also print it in a beautiful way by using format strings. These are different ways of printing the format string, like same thing and written a different way. Okay. You can also go and update the name. Say, for example, we have a P2 object in which it is saying that name of the person is Mary and age is 25. I want to go and update P2 dot age is equal to say 35. Okay. Let me initialize this. I'm printing the name and age, Mary and 25. I'm going to update P2 age to 35. I'm going to print the same thing again. You can see that values will get updated. We can also make use of docstring. Like in functions, you notice that the docstring is like within triple quotes. Like say, for example, if we have a simple function, df function name. I'm not going to pass any arguments. So this is a docstring, okay? This is docstring. Okay. I'm going to say print hello world. So when I declare the say function and when I say function name dot doc, it is going to do this. It is whatever is present in this doc string, it is going to print this, right? Similarly, in class, we have something called as underscore underscore str underscore underscore. In this, which we can say write some string object, and you can simply call the object. Say, for example, I declare this, and when I print p1, it is going to print whatever is there in my string function. It will say person name is so and so, age is so and so. Okay, you can make use of that. We can also have couple of functions to it. So the way you have string object, you can also have some functions to it. I can say my function. In this my function, I'm going to pass the self object, and then you can access all the variables that you have initialized. Say name of the person is self.name and the age of the person is self.age. As simple as that. Now you can access p1.age, p1.name. When I call this p1.my function, it is going to use this p1.age and p1.name, and it is going to print the object. That is how you can make use of functions within a class. In some cases, you might have a requirement of passing some foreign variable to it. So let us say that foreign variable is not part of my initialization, but you want to explicitly send that variable to my function. So how you can do that is, say the safe method is to use a keyword argument. So if you don't want to use a keyword argument, you can simply pass like this, okay? And it will behave as a normal argument. But given a case that you want to pass a keyword, you can also pass a keyword. So what I'm going to do is I'm going to initialize the object p1 again. I'm going to say person. I'm going to send the name and age. Whatever is there in the initialization, you will have to pass it no matter what. Because you have initialized it with name and age, you have to pass the name and age. And then when I call the p1.my function, you can see the foreign value is printed as a because you have defaulted it as an a argument. And similarly, if you want to pass the argument as foo, and then it will replace the value of a with foo, and it will do the same thing. Okay, that is how you can make use of classes. Don't require this. You can go and update the value, as I said. When you update it, it will update the age and it will print it. And after you're done with all your operations with this p1 object, you can also delete the p1 object by using del command. And once you have deleted, it will be wiped off from your memory. Of course, you will have to use some library like a garbage collector to free that memory. Though you cannot access this p1, it might be still be sitting in your memory. It is still be occupying that thing. So if you use some garbage collector, it can remove everything. It can remove those traces from the memory. It can free out that memory for future use. Okay. Now let us discuss something called as class inheritance. So far you've seen class, right? In class, you can have multiple variables, and also you can have multiple functions, and you can make use of those functions by simply calling that object dot function. Okay. Now let us say that you want to inherit the properties from one class to another class. So you will require two classes now. One is called as a base class or a parent class, and one is called as a child class or the dependent class. Okay. Now let us say that you have a school details, which is a parent class. Okay. Now have a school details. In this, I'm going to tell what is a school name and which year of admission it is handling. Okay. And I also have one function in parent class which says the admission year for so and so school is so and so. So for example, I have initialized this class. So now this is a parent class. Okay. In the child class or the dependent class, I'm going to take everything that is present in my parent. How you're going to take it is simply passing that parent object to the child object. Now this is my child class called student details. In this student details, I'm going to pass all the objects here. Okay, I'm simply consuming the parent class in my child class. This is my child class. This is my parent class. And in the child class, I'm not doing anything for now. Let us say that I'm not going to do anything. Okay, I've declared it. Uh, Before I tell you about more about this, let us say I go and access the student details. Okay, now I'll push this up. I'll push this up and I'll push this up. So how do you initialize a child object? By calling the child class, right? Student details. Now notice that in student details, you will have to pass that is required for parent. For parent, what you require? For parent, you require the school name and the year of admission. So how you initialize the student details is by passing the school name. Say for example, my school name is Python classes. Okay. My school name is Python classes and the year is 2024. This is how you initialize the child class. I have initialized it. Now in child class, you don't have anything. I have simply used pass. In child class, you don't have anything. Okay. But what it is going to do is whatever you have used the parent class, all this is available in the child class. So how you can see if it is available or not? In student class SD1, I'm going to look for what is my school name. So the school name was present in parent, it is present in child also. Okay, this is called as Python inheritance. Whatever you use from the parent will be available in the child. But on the contrary, whatever is available in the child might not be available in the school, in the parent. Okay, but of course you might not see that use case wherein you try to take some property of a student and then you try to see it in school. You might not have such use case also, but just keep that in mind. Whatever is available in the parent will now be available in child. So in parent, my school name was available. I can see that it is throwing the correct output. And also you can see year of admission, 2024. You can also directly use the parent class. Say, for example, school details is my parent. And in this case, I'm going to say the school name is, say, for example, blah, and the year is 2023, for example, 2023. So when I go and say sd.school details, it is going to print the year of admission for blah is 2023. Okay, you can also use parent class as standalone. If you want to use it directly, you can use it also. But on the other hand, if you want to use the child class, you can also use the child class. Say, for example, you have this. Okay, let me move it up. So in SD1, which is nothing but the child class, you are using the display school details. Where is this school details display school details present? It is present in our parent. So when I call this, it is going to print the print whichever print that is available in here. The admission for year so and so is so and so. So here again, the admission for year Python classes is 2024. That is how you can make use of Python class inheritance. This is a common thing which you will be using it. And even in data science, probably you'll come across a couple of functionalities like this, wherein you're writing a class. In this class, you're passing some other class. So this should be, unless and until you understand this Python class inheritance, it will be very difficult for you to move forward. So this is a very important concept. So if you do not understand, just hang on, repeat this topic of whatever I discussed. Okay. Let us move to a little more complicated part wherein you are declaring a couple of more arguments in the child class. So far, so good, right? So far, we have seen a session where we did not declare anything in the child class. Whatever we declared only in the parent class. Now, let us take one step ahead. Let us declare a couple of more arguments in the child class. How to do that? Okay, let us see. Again, I'm declaring student details to which I'm passing school details. I'm going to have an init function. In the init function, I'm going to capture all these values: the school name, the year of admission, the first name of the student, the last name of the student, and in the batch in which the student is going to get seated in. Okay. After you do this, because you have initialized from a parent object, let us initialize the parent first. How you initialize the parent is by calling parent init function. Now this is a parent. In this parent, you already have an init function. Where is our parent? This is a parent. This is a parent. In this parent, you already have an init function. For this init function, you need school name and year of admission. So what I'm going to do, I'm going to pass the school name and year of admission. See, I'm going to pass the same self object here, and I'm going to pass the school name and year of admission to this. So what internally it will do, it will call this parent object and it will run this self.school name is equal to school name, self.year of admission is equal to year name. It will do internally. Okay. And on top of it, we also require the first name, we require the last name, and we require the batch. So what I'll do is self.first name is equal to so and so, last name is equal to so and so, batch is equal to so and so. And on top of it, I will display the student details. So for displaying the student details, I have one more function, display std. I'm passing the self. I'm going to tell the first name space last name joined the school in batch on so and so year. Simple printout, okay? And then I'm also using the parent function, the display school details. I'm using this parent function here. Let us initialize this. And when I go and create an object called P1, in this P1, I'm going to say my school, year of admission is 2024. The student first name is John, student last name is Miller, and the batch is 2. So when I go and initialize it, and when I call the p1.display_std, it is going to print these two objects. So the first sentence is coming from the child. The second sentence is coming from the parent. So whichever function that is available in the parent is also available in the child. You can access this display std only within this class. So let us say if I want to go and call this display std outside the class, I cannot access it. It will tell the function name is not defined. It understands it's a function because you have kept a parenthesis. The name display std is not defined. Why it is not defined? Because you have defined this function within a class. So you will have to first call the class followed by the function name, and then it will do the same operation. Okay, just keep this in mind. And whatever variables that are declared in the parent is also available in this P1. You can notice that P1.school name is having my school, and P1.year of admission is 2024. And of course, the first name, the last name, and the display school details, they're all available. Okay. You can also make use of parent class if required. I can say SD is equal to parent class. I'm having blah in 2024. After you initialize it, you can make use of display std. This is called as Python inheritance, wherein you inherit the properties of the parent object into the child object. And whatever functions or variables that are present in the parent will be available in the child because you're passing the self object here. You're passing the self object. So all you update, everything you update in this parent will be available in the self object. And wherever the self goes, all of that will be available. Okay. This is a very important topic. If required, please go back and repeat what I have just said. Let us learn about Python encapsulation now. Encapsulation is like, in short, before I tell, whatever variables that you declare in the parent will remain intact, even if those variables are getting updated in the child class. Say, I will take one same base class. In this base class, I have a variable called val, and I update a value called 2. Okay. So I declared one variable called val, and the val is having a value called 2. So if you notice that I have declared base in object 1, I have object 1.val, I have 2. Okay. Now let us remove unwanted code. Okay. Now I'm taking a base class. I'm taking a derived class. In derived class, what I'll do is I will take my parent as base, and I'll initialize base as it is. This is, I think we already saw how you can initialize the parent object in child is by doing this. Yeah, there are two ways to it. Either you can call school details dot underscore underscore init, or you can use super init function. Both are same. Whichever is easy for you to understand, you can use the same thing. You can also use super init. By default, super init will call the parent class and it will initialize it, or you can also do it the same way, like this, how we did it. So in this case, I did base dot underscore underscore init. So what it will do is it will initialize this parent object, and then because you have initialized the parent object as self, the value that is available in the parent will be available here. So what I will do is I'll before updating, I'll just see what is the value that is available here. Okay. So when I go and print, after printing it, I'm going to update the value as 3. I have here just saw what is available in my parent. After seeing what is available in my parent, I'm going to update the variable to 3. Now what I'll do, I'll create object 2. Object 2 is derived. Okay. And object 2 dot value will print. So when I initialized object 2, it said it printed this because it is there in the init. By default, it will get called. And then it is saying that the protected member is 2. Okay. And now I have updated the value to 3. So whenever I access object value again, it will always tell it is value is 3. Okay. Now let us go and print, let us say I'll go and print object value to 3. This is obj1. I updated the obj1 value to 3. Okay. But even after, despite doing that, when I go and print obj2 again, let me not print this. When I do print this, when I do this, it will print as 2. So it is protected. Whatever you have declared in the parent class, it will remain intact. It will not get updated until you go and update the value here. Okay. So even if you go and update the value in the child class, the parent value will always remain same. Just keep that in mind. Of course, we will not be using this much. The next topic that we have for now is polymorphism. Uh, Polymorphism, in other words, is called as many forms. So what you can do is, like, for example, we have 3 classes which are very similar. We have strength, we have location, we have subjects. These 3 functions are available in all the classes. The classes are school, college, and university. Okay. So what I'll do is I'll just initialize them. Okay. And then I'll take 3 objects: object for school, object for college, object for university. Okay. I initialized. Now these 3 objects I have kept in one tuple, or you can even take list. It's just an iterator of all those classes. And I'm taking one object at a time for object in all these tuple of objects. Because all follow a similar structure, you can see the body remains same. The body remains same for all of them. You have the same function in all of those. So what you can do is, because I have used object here, now I can use object dot strength, object dot location, and object dot subjects to get the output. Now this is the called as polymorphism. Like, we will not be using this, but just in case if there is a need for you to iterate over multiple classes and make use of the functionality within the each class, you can make use of that. Okay, what we are going to use in classes, that is the main question. Okay, so far so good. Now, so until like whatever discussed so far, the main topic that we discussed is Python class inheritance. This is the main topic. Okay, if you do not understand, please make sure that you repeat it and practice it so that you get familiarized and used to it. Okay, where are you going to use classes for? Say, for example, it is not required for you to use classes, but it'll make your life easy if you get used to it. Okay, say for example, you are switching to a data science concept and you're trying to have one functionality. And in data science, what you have is, like, you try to load all your objects to memory. Say for example, you have a data sitting in CSV file. You're going to load it to a memory object, something by using something called as pandas. After that, you're going to, first is the reading step, second is pre-processing step, wherein you try to look at the data, handle all the missing values, convert all the text to numbers, and then you have a training and testing part, wherein you apply different models and then you try to train the machine to find out underlying patterns and you try to predict it. Okay, that is the uh, normal way of data science thing. Okay, in this normal way, there is one step called as pre-processing. Let us say that you have a task wherein you want to apply pre-processing for any structured data. Okay, you take any CSV file, and for any CSV file that is available there, you want to apply the same steps of operations. How do you do that? So you can make use of, you can write multiple functions and you can keep calling that functions and do that. One other way is to come up with a class. Okay, what I'll do is I'll simply write one simple class called preprocess, and in this preprocess I'm going to take one input path from where I have to take the data. Okay, I want to automate this so that I can apply it for any data that is available out there. And then what I'll do is, after reading the path, I have declared path self.path as path. This part till here, I think you already know. We have discussed this so many times. After this, I want to have one more function to read from path. So for reading the path, I have used one library called pandas, import pandas as PD. And in pandas, you have a feature called pandas.read underscore CSV, which you'll have to send the CSV path, and it will convert that file to a data frame, and it will store it in your variable. So even that variable, I'm putting it in self. So self.data is nothing but read underscore CSV. So this is your first function, which is reading. Now you have another function to show the first 5 records, show the next 5 records, and then it will show the describe. So before going this, let me show you a small details about pandas. PD. So I'll say df is equal to pd dot read underscore CSV. I'll say my CSV path. Say for example, I have a path here. I'll make use of this. So you have a CSV file. CSV file is nothing but it's just a simple Excel file wherein your data is stored. So if you want to see, let me show you. Let me go to the training folder and I'll go and open employee data.csv. I'll say employee data.csv. This is how a CSV file looks like. It is because you're opening that CSV file in Excel, you can see that in Excel file. Okay. It's just opening. Give me a minute. Okay, it opened and this is how the data looks like. Okay, you have a CSV file wherein you have couple of columns and you have couple of rows. It's a structured data, as simple as that. Now what you're trying to do is this file is located in your hard disk. Now you want any operations that you want to do in this, you will have to first bring it to your memory, because in memory you will be doing the operations. If I have to do it on the file directly, I have to do it manually here one by one, but I want to do it in an automated way. So let me load this into memory. How you can load it into memory is by using pandas. So I did df is equal to pd.read underscore csv. It reads that. So if you want to go and see the first 5 records, this is what you're going to do, df.head. And then if you want to go and see the last 5 records, you can see df.tail. And if you also want to have a generalized output, you can see df.describe. Okay, I will have a separate session about pandas at a later point. But for now, let us say that you have some functionality of looking at the first 5 records, the last 5 records, and the an overview of the data. What is the distribution? What is the count of records? What is the mean? What is the standard deviation? And so on and so forth. Okay, this is what it technically have. Let us say that we have only 3 features available for now. I'm going to have these 3 features. One way is to do this step by step. Other way is to have a class, write a function for reading, write a function for displaying. As simple as that. We are not doing anything fancy here. Okay, we have a class called preprocess. In this preprocess, I'm going to initialize it by taking one argument, which is nothing but the path of the file. And using this path of the file, first what I did was I created a variable called data. I kept it in myself. Self.data is equal to pd.read underscore csv. And another function which is going to tell, which is going to print the first 5 records, the last 5 records, and it is going to describe it. Okay, this is a simple class. Now I'm going to initialize my data object, data underscore class is equal to so and so. I have initialized it. If you want, I can go and say data, sorry, print data. I can also have an str function here. df underscore str. Let me return this. I think we have returned it earlier. I'll return this. Now, if I go and initialize this one more time, and when I go and print it, it is going to print whatever is there in my string class. This is a pre-processing step. Okay. This is optional. Like if you want to use it, this is just for our understanding. Okay. Now what I'm going to do is I'm going to call one function at a time. I have declared data class. In this data class object, I'm going to call my read path. I already have passed this path. So what it does is it will call this function. It will load the data that is available in the CSV file as a data frame, and it will store it in self. It is not returning anything. It is storing in self. That is why you don't get any output. Now, also you can call the next uh, display function, and it will display your output. Okay, it will display your output like this, like top 5 records, last 5 records, and then your describe function. On the other hand, let us say I don't want to do this. I don't want to call one function at a time. I want to just call one function that is present in the class, and it should do all the operations. Means it should call the read path first, then it should call the display path first, and whichever function that you want to call. So for doing that, what you can do is we can use something called as underscore underscore call underscore underscore, which will help you to write the script in whichever way you want to call, you can call. Say, for example, I have one more class to it, which is nothing but this underscore underscore call underscore underscore, to which you're passing the self object. And in this self object, in this function, you're calling the first function read underscore path. So this function will be called, and this data will be available. And then you'll call this second function display df. So after you initialize this class called preprocess, let us initialize one more object, data underscore cls2. I'm going to pass the same path again. This is the path where I have the CSV file. You can pass any CSV file you want. It will work for all the CSV files. Don't worry. We do not have any complicated steps in this class so far. Okay. If we are doing any complicated steps, then there might be some errors. But for now, you can pass any CSV file to it. Just make sure that the path is correct, and then it will work. Okay. CLS2. I'm going to print it. Notice I don't have a str now, so that is why it is saying that the main object is present in so and so memory. And when I call this CLS2, how you call it is by using parentheses. Okay, I have declared data CLS2,